Hello, and welcome to this two-part series in which we'll talk about Boost and how to troubleshoot the performance of boosted flows. In this first part, we'll look at what Boost can do and briefly how it does it, the configuration steps, what to consider for ECV, and a quick demo of Boost in action. In part 2, we'll see what happens if the network memory disk is too small, compare the right baselines, and dive into some troubleshooting tips. Boost is an add-on license for EdgeConnect, which provides performance enhancements by deduplicating data patterns and accelerating throughput. With a pair of EdgeConnects connected via an SD-WAN tunnel, each stores a copy of the transmitted data patterns on the network memory disk or disks. If those patterns are seen again, instead of retransmitting them in full, small fingerprints are sent over the WAN instead. Those fingerprints are used to serve the original data from the EdgeConnect disk, saving up to 99% of WAN bandwidth. More details about how Boost works can be found by searching EdgeConnect Boost using your search engine of choice. You should see a great video on our website, which walks through it in detail. Boost is configured in a few places, and all have to be set correctly for it to function. You can check your Boost allocations on Configuration Licenses on your orchestrator. Check each appliance at Config Deployment and verify the correct bandwidth has been set in the Boost box. Also, verify it has been enabled on the relevant overlay at Configuration Business Intent Overlays. We recommend enabling it on non-real-time overlays only, such as bulk apps and/or default overlay. Most of our hardware EC models already come with storage on board to support Boost. Once licensed, it's just a matter of enabling it on the overlays, if you haven't already. For ECV though, there are some additional steps needed. The most important is the provisioning of additional virtual disks for network memory. As deployed from OVA, for example, there is an additional 70GB disk present. This may be enough for small branches, but if your workloads are bigger than that in a given time period, often 24 hours, you may need to increase the disk size. We'll see what happens if the disk is too small in part 2. Please ensure you have consulted the EdgeConnect System Requirements documentation to ensure you have enough CPU and RAM to match your Boost bandwidth configuration. Next, a quick demo of Boost in action. Here we have a Windows client on a 100 megabits per second LAN accessing an SMB2 file share on a remote server. It's 80 milliseconds away, and we have 10 megabits per second of WAN bandwidth available across a single tunnel. We'll transfer a 100 meg archive, which contains a mix of compressed and compressible content. Without Boost, 9 megabits per second is the fastest we can go. With Boost enabled, and on the first pass, now we get a mix of speeds from 9 right up to 100 megabits per second. This is because payload compression acts on the compressible parts of the file, and this effectively accelerates it, even on the first pass. On the second and subsequent passes, you can see throughput reaches LAN wire speed consistently. So Boost has allowed us to transfer data at near LAN speeds of 100 megabits per second over a 10 megabits per second WAN. Depending how much data changes between passes, you may see it fluctuate as patterns available on the disk are served directly versus those missing which have to be transmitted over the WAN in full. In part 2, we're going to see what happens if the network memory disk is too small and dive into troubleshooting. See you there!